Oh, we've got a full house today. Good afternoon, everybody. Welcome to another exciting afternoon of Chem 170 with your host. Let me move the cursor out of the way. Me, Dr. White. If you notice, my eyes are working good. The cataract surgery, it's now been a week on this side, 3 weeks on this side. It's going magnificent. And I'm very lucky to have a great eye surgeon, Dr. Cabin, did a great job on my eyes. See? All right, a lot to do today. First of all, let me remind you that this Wednesday, end of the day, is the deadline for the extra credit project. It's optional, but it's 10, yes, 10 points. And one of your colleagues already did it and did it perfectly. It's not that hard. And before Wednesday, if you want, email me or come to my office hours, Monday or this Wednesday, and I'll check it before you upload it and help you tell you what needs to be changed so you can get your 10 points. Now, in a little while, I'll be going through test number 4 answers. You guys did really good and makes me so happy. Thank you, and thank you. But before that, I want to do something important, and that is a week from today is the final. Relax, take a deep breath. And if we look at, thumbs up, people, you see Chem 170 final, thank you. The final exam will be given next Monday at 1 p.m. At that time, we will not have lecture. This is the final. I will be emailing you the password for the final exam PDF file. You'll have until next day, Tuesday morning, 10 a.m. to take the final and upload your final as a single PDF file. If you need to, take up to 3 hours, but most students, when I do it face-to-face, are usually done within 75 minutes or 90 minutes for my final. Now, the final exam will be comprehensive. It has 32 problems, 18 pages. Relax, relax. It's essentially a double of what a normal test is. There are multiple parts, but no multiple choice. I've never, ever done a multiple choice problem in Chem 170. Now, there's 2 ways to break down what goes on the final. One is there are 30 points on general knowledge, 62 points on nomenclature, 118 on reactions. And it adds up to, 210. That means there's 10 bonus points. Each hourly exam, there was 5. So the final is twice the points. So I made it 10 bonus points. Now, remember, nomenclature, there are 2 types of questions. Here's the structure, give the IUPAC name. The other is, here's the commoner IUPAC name, draw the structure, except for amines, which you'll be allowed to put the common name down for nomenclature given a structure. Now, reactions, most of them will be give the product or products for the following reaction. I don't know how many, but just a few will be give the starting materials. Now, I also have on material test number 1 material, there's 35 points on the final. Test 2 is 60, test 3 is 58, test 4 is 53 points, and new materials, amino acids and proteins, are 4 points, and that adds up to 210. And you'll be able to download the final exam on Sunday before that Monday or next Sunday. If you have any questions during the final exam, email me. And I'll also, during the first hour on Monday, I'll be on Zoom, so you can also come there. And I'll also stick around for an hour, my office hour that Monday night. So if you have any questions, feel free to stop by. I'll be posting the final exam with your scores with your final test grade by Friday of next week. Not this Friday, a week from this Friday, 1 p.m. or earlier, hopefully earlier. And at that time, I'll post an announcement and send out an email that all your scores and final grade are in D2L. And it usually sometimes takes, once I post them in the school system, about 24 hours and ECC My Access or whatever they call it. But what I post in D2L will be the official grade. Now, the best way to study for my final is use your hourly exams as practice problems. Will I put the same problems on the final? No. But will I put similar ones? Of course. If you look at the chapter practice problems, those were similar to what you saw in the final for tests 1, 2, 3, and 4. They weren't the same, but they were very similar. And I'll do the same with the final. All right, any questions about the final exam? All right. What I'd like to do is go. Anybody have any questions? I would have a question. What do I need on the final to get the grade I want? Well, let's go through that right now. If you look on D2L, you'll see not only do I have your tests 1, 2, 3, and 4 score, but I also have your test total. And let's say X equals, I'll call test total, plus the extra credit I could spell. So with this, I'm going to ignore the labs. If you've handed in all your labs, which is everybody but one person has, you've gotten good scores. And this works quite well. X is the test total plus, which is the 3 highest tests. Now, I'm not going to go any lower because nobody's in that ballpark, thank God, in this class. And if you look at to get an A, this is an approximate, but it's usually quite accurate. 450 minus X equals the number of points you need to get an A. And 400 or more, 400 minus X is the minimum amount of points you need, or points you need on test, final exam, not the test, to get a B. and 350 minus X is the number of points needed to get a C. Let's say you did real good on each test and your X, and you didn't do the extra credit, you should, but you didn't, was 300. You got 100 on each of the 3 tests, or all 4 of them, but I only take the top 3. So 450 minus 300 equals 150. And you look at that and say, oh my God, that's a lot of points. No, not really. Think about it this way. The final is 210 points. My tests were 105. If I divide 150 divided by 2 is 75. To get a 150 on the final is the same as getting a 75 on an hourly exam. So it doesn't look that bad. Now, one thing I should caution you. I've had students who've been in a position like that. Oh, I don't have to get that many points on the final to get my A or B. So guess what? They don't study that hard or not at all for the final. And they do real bad. I mean bad, like 100, 120, and it drops them a whole letter grade than what they should have if they had studied. So my advice to you is, even if, and many of you are in a good shape, thank you, thank you, thank you, study like you need every point to get the grade you want. Study like you need every point to get the grade you want. Any questions on that? Looking at what I'm supposed to do today. And guess what? It's time for a little surprise from Dr. White. I'm going to cut this out of the video. All right. Most of you, like all of you, have never been in a chemical plant. Sorry about being 60 seconds late. Yeah, Dr. White. Oh, excuse me. All right, quick thing I don't know if I mentioned earlier, but I'll mention it now. This Wednesday, after lecture, I will talk about the best, how should I properly phrase this? I'll give you tips how to interview, how to successfully interview. A, either to get into school or program, or B, how to get a job. I definitely will cut that out of the video. In my career, at my level, jobs I've held, generally I have to go back for a second interview. Usually it's with the CEO or president of the company and vice president. And I know how to interview, plus I've hired people, so I know how to interview. And I've given this a couple of years ago, I started doing this, and students have really been helped. And I'll talk more about that Wednesday. It's optional, but come to a lecture Wednesday and you'll hear that. All right, what I like to do, and I've done this before, is I'm going to be doing, starting now, a review for the final exam. And let me open up something. What I'll do is go through the reviews for the test, but I'll also emphasize things you should know. All right. Everybody see test one review? Thumbs up, people, on your screen. Thank you, Joe. All right, let's go through this. And these are things you should know. What's a hydrocarbon? It's a molecule with only carbon and hydrogen atoms. This file is in the lecture section of D2L. And you should know, what is a saturated hydrocarbon? A molecule with only carbon and hydrogen atoms, only a carbon-carbon single bond. What is unsaturated hydrocarbon? Now, that's molecules with only carbon and hydrogen atoms and at least one carbon-carbon double or triple bond. Now, alkanes, I'll never ask, but those are acyclic, meaning not in a ring. Saturated hydrocarbons, I'll never ask on a final. Oh, I gave it away. What's a cyclic cycloalkane? That's cyclic saturated hydrocarbons. But I did teach you how to draw them. I talked about IUPAC rules, and I showed you how to find the longest chain of an alkane. And then we talked about the alkane names, 1 through 10, which you learned methane, ethane, and so on through decane. Next, I talked about alkyl groups. And there we have methyl, ethyl, N-propyl, isopropyl, N-butyl, and tert-butyl, which after the first or second week of class, being a lazy organic chemist, we really call it a T-butyl group. These are the alkyl groups you should be familiar with. Now, on test one, I asked you how many carbons are the longest chain. I'm not going to ask that on the final, but you'll have to know how to do that for nomenclature on the final, which you've done in test 1, 2, 3, and not so much 4. Now, I never corrected this. Anybody find any gooseline around? But anyways, real world uses you should know for the alkanes are gasoline, propane for your barbecue, natural gas, Vaseline, and baby oil are examples. Now, the only reaction I asked you to learn was if you take an alkane or cycloalkane, react it with oxygen, what do you get? CO2 and water. And that was on test number 1. And next we got into double bonds. But before we do that, let's do this. Let's have some little practice. And why not try this one? Give the IUPAC name for the following. I've got you guys trained for thumbs up already. Well, we've been doing that. That's one of the things of Zoom. In a classroom, I'd be able to look around and see when everybody's done. All right, I think everybody's done. Let's do this. What's the longest chain? Well, this one, I didn't trick you like I did on test number 1. Go back and look. The longest chain is hexane. And once I say hexane, this is all spoken for. And look what's left over. It's your old friend, the methyl group. And there are 2 of them. So that's dimethyl. Remember, di, 2, tri, 3. Tetra is 4, but I've never encountered that, and you won't either. And if we start, this is carbon 1 right here, the methyl groups are on 2 and 3. When you have dimethyl, you need 2 numbers, even if they're on the same carbon. That'd be 2,3-dimethyl hexane. Now, another nomenclature question is, and don't forget for ring, use, before we do this one, let's do another one. And there you go. What would be the IUPAC name for that compound? This is why students do good on my final, because if you come for my review this week, you'll have about 4 hours of study with me for the final, which can only help you. Just about everybody's just about done. Think about it. 6 months ago, would you even know what to do? Probably not. All right, let's look at this. We have a ring. How many carbons? 1, 2, 3, 4, 5. Every bend in a line every bend in a line in a ring is a carbon. 5 carbons pentane, but it's a ring. Common mistake on the final exam, students forget to put the word cyclo. I mark it wrong. Please don't. And then what do we have here? Oh, it's Dr. White's favorite, tert or T-butyl group. When there's only one substituent on a ring, you don't use a number. So that's T-butyl cyclopentane. And why don't you do the following? Draw the following 1-methyl-3N-propyl cyclohexane. Thank you, Joe. Thank you, Megan. Remember, I thank you, Calvin. All right, I'll assume Emily's done. So let's go through. How do you decode this? You start from the right, move left. Hexane 6, cyclohexane, a ring. And on carbon 1, which most of you are going to put up here, is a methyl group. You go clockwise or counterclockwise. Most of you are going to go clockwise, is propyl 3N to the N carbon. And there you go. All right, let's get back to test number 1 material. Next, I talked about, now we got into exciting stuff. Alkenes, double bonds, alkynes, triple bonds. And you should know a double bond has 1 pi bond, 1 sigma bond. A triple bond, alkynes, has 2 pi bonds, 1 sigma bond. Now here, I made a mistake, and I'm too lazy to go back and correct this. For IUPAC, double bond, name the longest chain with both carbons double bond, drop the ANE and replace it with ENE, and you need a number for acyclic, those that are not in a ring, plus whether it's possible cis or trans. If it's in a ring, you drop the ANE ending like cyclohexane, cyclohexene, no number, because one of the carbons of the double bond will always be carbon number 1. That's the only functional group, which will be true in this class. Both these have 4 carbons, butane, they have a double bond. Therefore, you have butene. Starting from either end, the lead carbon is 2. Same thing here. But notice if I had a plane right here, these hydrogens are on the same side, like below my hand. And same side is cis. If I had that same plane, or think of your hand, one is below, one is on top. And that would be trans. And again, cis is the same side of that plane. It's orthogonal to the double bond, and trans is opposite. And you should know that. And if you go back and look at test number 1, I have examples where I ask you that. Both here's the structure, draw the name, give the name. Here's the name, draw the structure. Now, when it came to reacting double bonds, and they're a lot of fun to do, the first reaction I showed you was if you take a double bond, react with a hydrogen and a catalyst, the catalyst can be nickel, platinum, or palladium, you break the pi bond, and each carbon gets a hydrogen. Again, you have a double bond, you only break the pi bond. And for the final exam, your friend will be the following. 1, how many bonds to carbon? 4. I'll say it again. Your friend on the final, how many bonds to carbon? 4. Over the years I've been teaching 170, if students remembered that, I'd say half of them, if not more, of what they wrote down wrong. They would have said, that can't be right, because I don't have 4 bonds to carbon. I have too many or too little. The other friend on the final, do you break carbon-carbon single bonds? No, You don't break carbon-carbon single bonds. And let me show you, remind you. If I were to ask you, give the organic product or the products or the following, and I'll do this one, and I look here and say, oh, what's different? When you look at an organic molecule, you should look for what's not a carbon-carbon single bond, or what's not carbon or hydrogen, and that should get your attention like that did, or that did. And here we have a double bond. So immediately all I see is a double bond, hydrogen. This is a catalyst. Catalyst can be nickel, platinum, or palladium. And you break the pi bond. Remember, this is one pi bond, one sigma, which you don't break. And each carbon of the double bond gets a hydrogen. Well, that's this. I have 4 carbons. You break carbon-carbon single bonds? No. So I'm going to end up with 4 carbons. Here are my 2 carbons of the double bond. Notice there's only one line there. So I broke the pi bond. Each one gets a hydrogen. And now I know there are 4 bonds to carbon, and I can fill in the rest of the hydrogens. And as I taught you when we first learned this, you want to leave it like this instead of writing this one CH2, this one CH3. That's fine for me. You know why? I'm that close to the person who grades the final. Me. Oh, I'm going to have you try one. Why not? Give the organic product or products for following reaction. 3 points each. Thank you, Megan. So after this semester, you can tell your neighbors, loved ones, and family members, I know organic chemistry and it was fun. You don't have to. All right, I think everybody's done. What do we have that's different? A double bond reacting with hydrogen, and nickel is a catalyst. Remember, the catalyst can be nickel, which in this case it is, platinum, or palladium. And you break the pi bond, and each carbon gets a hydrogen. Well, here are my 2 carbons. Do you break carbon-carbon single bonds? No. So I have my ring. I'll still have my 2 methyl groups. And I'm done, because you don't show hydrogens on a ring. If we look at this carbon, it has 1, 2, 3, 4 bonds, which means 0 hydrogens. If we look at the same carbon, it has 1, 2, 3 bonds. 4 minus 3 equals 1. So there actually is a hydrogen, but we don't show it. And conversely, the top carbon right here, whoops. Clicked on the wrong thing, sorry about that. Aren't you glad Dr. White has a decent memory? This type carbon has one hydrogen, and now it has two. So you have added hydrogen. All right, let's go back to reactions from test one for double bonds. Remember, I taught you X is the abbreviation for the halogens fluorine, chlorine, bromine, or iodine. If you take a double bond, react it with halogen gas, you break the pi bond, each carbon gets a halogen. Now, these were symmetrical additions. You had the same to both carbon of the double bond. What happens when it's unsymmetrical? Double bond HX, in this case, X is chlorine, bromine, or iodine. You do not ever want to work with HF, at least I didn't. And you break the pi bond, one carbon gets H, the other gets X, and it follows Markovnikov's rule. What's Markovnikov's rule? The carbon with the most hydrogens gets the H, the other gets the X. Now, if we look at this problem right here, what's different in the molecule? Double bond. What am I reacting it with? HX. Remember, X can be chlorine, bromine, or iodine. You break the pi bond, one carbon gets X, the other gets H, and it follows Markovnikov's rule. I never asked, do you people know how to read cursive? Next, can you read my handwriting? Good. My other class, which is a level 100 introductory chemistry at the other school, none of the students can read cursive, which is quite sad. But anyways, so what's Markovnikov's rule? The rich get richer, the poor get poorer. In other words, the carbon of the double bond with the most hydrogens gets the hydrogen. The other carbon gets the halogen. This has two, this has one, which is the greater number. Hopefully you pick two. Wasn't the math hard this semester in my class? And the hydrogen will go to this carbon and the halogen, in this case, chlorine. And now I put in, and you should know how to do that. And again, go back, look at test number one. There are problems like that. Now, the similar type reaction, double bond, acid catalyst, H plus, and water. Think of water as H and OH, and you break the one pi bond, one carbon gets H, the other gets OH, and this follows Markovnikov's rule. Again, double bond, acid catalyst, that's what H plus is, water, which is OH and H. You break the pi bond from the HOH, water, one carbon gets H, the other gets OH, and it follows Markovnikov's rule. And I better share the fun, so I don't have much time left. This is our last full week together. Oh, that's sad. Your turn. Give the organic product or products for a following reaction. In case you haven't started studying yet, I'll help you out. My first grade teacher would be happy seeing how well I write. Because she's looking down somewhere on heaven. So I'm sure she's long gone. I see a couple of you are done. We'll wait for the rest. All right, let's get going. If I look at this molecule, what do I see different? Ooh, a double bond. And we're adding acid and water. And here's the general reaction. Acid and water, think of water as HOH. You break the pi bond, one carbon gets H, the other gets OH, and it follows Markovnikov's rule. Oh no, I don't see any hydrogens there. Remember, Mother Nature and Dr. White love rings students don't. And if we look at these two carbons, if I count bonds, top one has 3, 4 minus 3 equals 1. So this has 1 hydrogen. The bottom one is 4 minus 4 equals 0. So this has 0. Which is the greater number? Hopefully you pick 1. And we break the pi bond. We don't break carbon-carbon single bonds, so that ethyl group will be there. And the OH will go to this right here. The hydrogen went there because this has 1. Now 4 minus 2, it has 2 hydrogens. And that's how you do it. Next, I talked about triple bonds. Real quick nomenclature. You do not have sister trans and triple bonds. And here, notice the triple bond, longest chain is 5, pentane. Drop the ENE, put YNE for pentyne. You find which one of these carbons is close to the end of the chain. 1, 2, I went this way, 1, 2, 3, 4, which is a smaller number. Hopefully all pick 2, and that would be 2-pentyne. Remember, this tells you YNE ending, triple bond. And you can't have a triple bond in a ring, at least I've never seen one practical. So you're not going to see one of my tests either. Now, a triple bond has 2 pi bonds. And therefore, you need, since organic chemists are lazy, we don't want to balance chemical equations. So someone came up with the concept, put the reagent, then bracket the letters X and S, close bracket. That tells you you have all the reagent in the world to react whatever, anything it could react with. In this case, a pi bond, 2 of them. And for each pi bond, each carbon of the multiple bond gets a hydrogen. 2 pi bonds, each carbon gets 2 hydrogens. And for a halogen, same thing, using excess, each pi bond gets a halogen. 2 pi bonds, each carbon of a triple bond gets 2 halogens. Remember, you don't break carbon-carbon single bonds. Now, next, I talked about aromatic compounds. And the first one I talked about is benzene. And that's both the common and the IUPAC name. And benzene is a ring, 6-membered ring that can be thought of as 3 double bonds or with a circle. And I taught you about the localized pi electrons from the double bond, that they're all holding hands together. Now, common mistake on the final and test number 1. Oh, it's cyclohexane with 3 double bonds. Cyclohexatriene. No, it's benzene. Remember, if on the test, if you just put this down, that's cyclohexane, and I'll mark it wrong. Benzene, you can either draw this or another resonance form, or, which I don't like because I think these look cooler, the delocalized like that. This is cyclohexane. These are benzene. Now, when you have a methyl group on a benzene ring, that's called toluene. And next, for disubstituted, use not the numbers, but ortho, meta, and para. And what do I mean by that? One, benzene ring. Two, notice it's disubstituted. And we counted either way, 1, 2, 3, 4, the other way, 1, 2, 3, 4. This is disubstituted, di means 2, and this is 1, 4, disubstituted. So this would be para, T-butyl, ethyl, if I can spell it right. Near the end of the semester, my spelling goes downhill. Did you buy that? Benzene. Remember, 1, 2 disubstituted, ortho, 1, 3 meta, and 1, 4 para. And I got to do this one more time. I can't resist. Everybody know what that is? It's paramedic. See, near the end of the semester, I can come out with bad jokes. Now, at this point, I introduce you some new substituents. Cl is chloral group, F is fluoro, Br bromo, I is iodo, NO2 nitro. And if you remember, again, all this you're saying is in test number 1, review PDF file in D2L in the lecture section. If you look at this compound, it's got a methyl group on a benzene ring, so it's toluene. It's got not 1, not 2, but 3 nitro groups. NO2 is nitro. And that would be tri-nitro. Now, when there's more than 1 group on a toluene ring, the methyl group is 1. This would be 2, 4, 6. So this is 2, 4, 6 trinitrotoluene, otherwise known as TNT. Very explosive. Now, with benzene, you don't break the pi bonds of those double bonds because you lose the stability of the molecule. And it doesn't want to do that. And therefore, you have what's called electrophilic aromatic substitution. You replace one of the hydrogens on a benzene ring with something. Now, the first one is halogenation, where now, because you're dealing with a benzene ring and you're not breaking the pi bonds, you fair tray halide catalyst. And X in this case in real life, this is chlorine or bromine. And you replace one of the hydrogens, in this case, whatever X is. Now you get inorganic stuff, but remember on my test, I'm just asking to give the organic product or products. Remember to draw the 3 lines in there in a circle. Otherwise, that's cyclohexane. I had a student lose 8 points on a final, maybe more. I take it back, 9 or 12 points, because that student forgot to put those lines or circle in. That's hexane, cyclohexane. Now, when you take nitric and sulfuric acid together, you make nitronium ion, NO2, and you put a nitro group on there. When you take sulfur trioxide and sulfuric acid, you put a sulfonic acid group on there, which can be converted into something that's used for your laundry detergents. If you put NO3 here, forget the hydrogen, I marked that wrong. And finally, Friedel-Crafts alkylation, that's putting an R group on a benzene ring. This is one of those special times that you can make a carbon-carbon single bond. Now, one of the important things in the lab, I introduced you to it, but in the test I said I wouldn't. That's what if there's something on the ring? Those are called the directors. That tells the incoming group X, nitro, sulfuric, or R where to go. Well, I'm not going to teach that because I wanted to spend more time on other things that you would find in your daily life. And therefore, all these reactions will always start with benzene. And this reaction, nitration, is the only one I can give you on a final. The sulfonation is the only one. And let's look at the last one. I'll let you try this, but since you probably haven't started studying for the final, you should, but you probably haven't. I'll help you out. And there you go. Give the organic product or products for the following. And remember, if you want to watch this again sometime, probably tomorrow, because tonight I got some stuff I have to attend to, I will be posting today's video in our YouTube channel, which I've done all semester. Thank you, Megan. Thank you, Joe. Everybody done? Not yet. Thank you. All right, what do we have here? Benzene ring. What's different here? Ooh, a halogen on a carbon. This is my R group of RX. Remember X, and I forgot to put this down, is usually, actually, I think X could be chlorine or bromine. For this, realistically, it's usually chlorine. And you put an R group, you make a carbon-carbon single bond on the benzene ring, and the bond from the benzene ring to the R group is to the carbon that has the halogen. So I have my benzene ring, What's our three carbons? Which carbon has the halogen in the center? Do you break carbon-carbon single bonds? No. I've just made isopropyl benzene. And that's everything for test number one. I highly recommend you go back and do test number one yourself for practice problems. I gave you some, but all right, let's go on to test number two. Now we got into some really fun stuff. The first functional group I talked about was alcohols. What's an alcohol? Hydroxyl group OH on a carbon. And how do you name them? You find the longest chain or ring with the hydroxyl group on it. You drop the E, add OL. For acyclic, you need a number, and that's given the lowest one, meaning that carbon should have priority, and given the number closest to the nearest end of a chain. If you're in a ring, you don't use a number because that's going to be carbon number one. And one special alcohol, phenol, or some people call it phenol, now it's phenol, is a benzene ring with a hydroxyl group on it. That's both the common and the IUPAC name for that molecule. Now, we started to get into what's called common names. And these were names used long before IUPAC, which came around about 1918, 1920. But these names have been used for eons. And for alcohol, how do you name it? Well, name the R group as an alkyl group it is, and add the word alcohol at the end. And I taught you rubbing alcohol as 70% isopropyl alcohol and 30% water. And now you can even buy up to 90% isopropyl alcohol and 30% water. Now, how do you make an alcohol? Well, this is the only reaction that was on two tests. We went through this just a couple minutes ago. Take a double bond, react with acid and water, break the pi bond. One carbon gets H, the other gets OH. And this follows Markovnikov's rule. Now, one of the more difficult reactions of alcohols, is this one called dehydration. And this is, if I take an alcohol, react with sulfuric acid, the little triangle is heat. Sometimes I will put 180, a lot of times I don't. You'll get a double bond. And this follows Zasev's rule. You'll get the double bond that has the most hydrogens directly bonded to the carbons of the double bond. Whoop. I'll do this one. We have the following reaction right here. What would be the product or products for the following? Now, if we look at this, what do we have? A hydroxyl group on a carbon, an adjacent carbon with a hydrogen. Here's my carbon with the, and if we react it with sulfuric acid and heat, you get a double bond and follows Zasev's rule. And I've modified it for this class. And if we look here, we have this carbon here and this carbon here. And if I lose the hydrox group and a hydrogen from A, I'll form this alkene double bond. If I lose this hydroxyl group and B between that carbon with the hydrox group and the carbon with B, I'll form a double bond. And Zayseth's rule is you get the double bond, the alkene, the way I'm teaching it, that has the most carbon atoms directly bonded to the carbons of the double bond. In A, we have this, 1. I'm going Technicolor on you. In B, remember carbon atoms, 1, 2, 3. And the question is, which is the greater number? Time's up. Hopefully all pick 3. And therefore, this is the correct answer. And that's how you do Zayseth's rule. Any questions on that? Well, it's time for a break. Let's take a break right now. Come back in 5 minutes. That'd be 2:51. And we'll continue. 5-minute break time. I can get up and stretch. can use this one. Everybody back? All right, one of the things I want to talk about before we get back to alcohols is the following. Oops, wrong thing. The following. Leaving my class, there's important things you should know. Hint, one is how does soap work, which I just went through. The other thing is you should be able to describe with words and a general reaction what happens when one, you eat, ooh, wrong color, right color. Something that has a fat or oil in it. And what's the key functional group in a fat or oil? An ester. And that's acid hydrolysis of an ester. And that's how you describe it with words. What's the general reaction? You learn this for test number 3. If you wanted to, you could also put HCl. Either one works for me. And you take an ester and you treat it with acid water, acid hydrolysis, and you get back the carboxylic acid and the alcohol you would have used to make that ester. So you should know when you eat something with a fat or oil in it, it's acid hydrolysis of an ester, and the general reaction is ester, acid, and water. You get back the carboxylic acid and the alcohol you would have used to make that ester. Next, when you eat a carbohydrate, how do you describe that with words and a general reaction? And what holds glucose together? You learned that's an acetal linkage. So it's in your stomach, which has acid. That's always a wonder of nature or life that I and you have cells in our stomach that make hydrochloric acid. And there's water in there. And the functional group holding glucose together is an acetal linkage. And from test 2, you learned this general reaction for acetals or ketals. Take an acetal or ketal, H+. You could have also put HCl there. Either one works. Water. And you get back the aldehyde or the ketone you would have used to make that. Acetal plus the alcohol you would have used. For those who must, you could put a 2 there, but that's not necessary, which is why I'm making it as small as possible. And you should know when you eat a carbohydrate, how to describe with words and a general reaction of what happens in your stomach. And I believe it's one of your 2 intestines. Someone corrected me years ago. I always forget. And finally, when you eat something with a protein, how do you describe this with words and a general reaction? What's the functional group in a protein that holds amino acids together? And that's an amide. And in your stomach, there's acid, there's water, and we call that hydrolysis. and the functional group is an amide. And for test 3, you learn if you take an amide, react it now, put HCl, because you're going to have to put down an amine salt, acid and water, you get back the carboxylic acid you would have used to make that amide, plus the amine salt. Whoops, Dr. White got carried away here. The amine salt of the amine you would have used to make that amide. So when you eat a protein, how do you describe that with words and a general reaction? The functional group that holds amino acids together is an amide. Therefore, you have acid hydrolysis of an amide. And the general reaction is an amide, HCl and water, you get back a carboxylic acid plus the amine salt of the amine, you would have made that amide. So once again, leaving my class, there are 3 things you should know. When you eat a fat or oil, how do you describe that with words in a general reaction? Acid hydrolysis of an ester, and here's the reaction. When you eat a carbohydrate, how do you describe that with words and a general reaction? Well, the key functional group you're reacting is an acetal, and it's acid hydrolysis for an acetal. And here's the general reaction. Acetal or ketal, acid and water, you get back the aldehyde or ketone plus the alcohol you would have used to make that acetal or ketal. Finally, if you eat a protein, what's the key functional group in a protein? And that is an amide. That's what holds the amino acids together. And that's acid hydrolysis of an amide. And here's the general reaction you learned for test number 3. Now, on Wednesday, I'll review again proteins, because there'll be about, 4 to 6 points on the final on that. I don't have a practice problem, so I'll go through it on Wednesday. And I wanted to do that. And now let's get back to alcohols. Reactions of alcohols. Remember, alcohol, OH on a carbon. Reacted with HX, where X is chlorine, bromine, or iodine, you replace the hydroxyl group with X. On the carbon, the hydroxyl group was originally located. Next, because HX can react with double bonds, someone came up with, if you take an alcohol reacted with thionyl chloride, SOCl2, you replace the hydroxyl group with a chlorine. Now, when we come to alcohols, and I'll never ask this on the final, you've got that on video. But anyways, take a primary alcohol and oxidize it. And the O in the bracket means oxidizing reagent, which I didn't make you learn potassium permanganate or sodium or potassium dichromate. There are others too. I just use the general way we designate that. Use a hydrogen from the hydroxyl group, hydrogen from the carbon that it's on, you form a carbon-oxygen double bond. And later you learn this is called an aldehyde. And if you take a secondary alcohol and oxidize it, same thing, lose the hydrogen from the hydroxyl group, hydrogen from the carbon it's on, form a carbon-oxygen double bond, and that forms a ketone. Now, tertiary alcohols will not react, and I've mentioned this before, and I'll mention again, I will never put on a test or a final a reaction where the answer is no reaction. If I ask you, give the reaction product or products, there will be a product, which is why I don't have tertiary alcohol oxidizing. Now, next I talked about thiols, and thiol is the sulfur analog of alcohols, where instead of oxygen, OH, you have SH. Now, the important thing about thiols are they stink. Oh, do they stink? And you should also know natural gas, which I asked this on test number 2. Natural gas has an odor. Methane does not. Well, how come you can smell it? Because that tragedy in Texas at the school for that town, where all those children and teachers were killed or badly injured in the early mid-1930s because of a gas leak they couldn't smell. And now they put thiol in natural gas so you can smell it. I didn't do any nomenclature reactions with thiols. Now, next, I talked about ethers. Ethers are oxygen with carbons attached to it. And I didn't ask you to learn diupac, but the common name for ethers, name each R group as an alkyl group it is, and then add the word ether. Now, there was only one reaction I asked you to learn for ethers. That's the Williamson ether synthesis. Take an alkoxide, RO minus, Na plus. Dr. White's about to sneeze, so if I look like I'm being funky, that's why I'm trying to stifle it. I think I did. And an alkyl halide where X can be chlorine, bromine, or iodine, and you get an ether plus a salt. And the carbon with the halogen is the carbon bond to the oxygen in your ether. The carbon with the halogen is the carbon, the oxygen is bonded in your ether. So let's have some fun with ethers. In case you haven't started studying, hopefully you will this week, I'll help you out this one time. Oh, I forgot to put something here. And it's your turn. What would be the 2 starting materials for the following reaction? And while I've got all of you here, I'm going to do something totally anonymous. Now, the question is going to say on there, are you done? But replace that question with the following. Is this review helpful? Yes or no? And I'm going to launch it now. And this is totally anonymous, so I don't know who's saying what. All right, looks like it is useful. Thank you for your feedback. I sort of knew that, but I still like to ask because it's not polite to assume. It's also not helpful. I had a great mentor, Sid Shapiro, and he used to always say, never assume because you become the first 3 letters. He was right. Every time I've ever assumed, I get burned. And when you're done, give me a thumbs up. All right, let's move on. How do you do this? Look for what's different. Ooh, an oxygen with our groups here and here, it's an ether. I'll call this R, and notice I made it easy for you, this R prime. Therefore, R is 3 carbons. Which carbon has the oxygen? Still has the oxygen, the end one. And remember, there is 4 bonds to carbon. So you know how to put in the hydrogen. Then here, this is my R prime. Again, 3 carbons. But which carbon is bonded to the oxygen? The end one. So the end one will have the halogen, in this case is iodine. If you react 2 together, you'll get that ether. Now, next I talked about, at first glance, say, oh, that's an ether, but it's not. And that's an epoxide. And I only talked about one epoxide, ethylene oxide, which I'll never ask on a final, what's the structure or what's the name of this molecule? But you should be familiar with it because I will ask reactions. And I only showed you there are a lot of reactions, but I only taught you the reactions of an alcohol with 1 mole of ethylene oxide, you get this ether alcohol. If you have N moles of ethylene oxide, you get this polyether alcohol, where this is the formula. Now, listen carefully. Common mistake on the final and test number 2, students put the hydroxyl group inside the bracket right here. No, it goes outside. Oh, I have to have some fun with ethylene oxide. And Calvin, who's ever leaving, say goodbye from Dr. White. Do you still have face-to-face classes down there? All right, now in case you forgot, I'll help you out now, but not on the final. And have fun. Don't forget tonight, if you need any help, I have my office hours in 15 minutes. And if you haven't done your extra credit project and you're planning on it, come on by and stop by if you need any help. Or don't forget, you can email it to me before you submit it to D2L, and I'll let you know whether it's right or wrong. One of your colleagues already did a great job. And remember, as some students erroneously think, for each of the 10, they don't have to be a separate functional group. They could all be alcohols or double bonds or whatever, or any mix. All right, if you're done, give me a thumbs up. Thank you. All right, what do we have that's different? Ooh, an alcohol. And what's my R group? This. Ooh, I have ethylene oxide, and I have 5 moles, so N is 5. So I will not break carbon-carbon single bonds. Now I'll still have that methyl group. This carbon will have OCH2, CH2. What is N? 5. And notice the hydroxyl group is on the outside. Oh, wait, well, anybody might be copying that down. All right, let's get back. Next, I start talking about one of my favorite areas, and that's aldehydes and ketones. Speaking about which favorite things, don't forget to look at test 2 and test 3 and play that fun game, circle and name the functional group, 2 points each. Everybody catch that drift? Don't forget to practice playing that fun game, circle and name the functional group, 2 points each. It's in test 2, and it's also in test 3. Now, an aldehyde, which is a carbon double bond to oxygen with a hydrogen and R group on the carbon double bond to oxygen, called the carbonyl carbon. You find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, add Al, ending. No number, because the carbonyl carbon is always number 1. It rocks, it's the coolest. And all substituents you name, just like you normally name substituents. Now, there's one exception, and that is when R is a benzene ring, IUPAC, in their infinite wisdom, and I truly mean that, said, organic chemists for centuries have called that benzaldehyde. We're not going to change them. So the IUPAC name is benzaldehyde. If you remember from the lab where you smelled aromatic compounds, we actually saw the results. We were in the lab. Benzaldehyde smells like cherries and almonds. And whenever I have a Dr. Pepper, which I like, yes, I'm a pepper. I'm also a doctor. Oh, that was bad. I can still do bad ones last week of the semester. I think of benzaldehyde. If you ever have marzipan in something, which is an almond paste in European goodies, really goodies, I think of benzaldehyde. Now, ketones, now aldehydes you cannot have in a ring. It's impossible. Now, ketones, if you have acyclic, first of all, ketone, carbon double bond to oxygen with carbon and carbons, and you drop the E and add ONE. And for acyclic, you need a number. If it's in a ring, that carbonyl carbon is always number 1. And why don't you try this one? What's the IUPAC name for the following molecule? 3 points each. Oops. Uh-oh. I forgot a hydrogen. One of you should have caught that. Thank you, Megan. Remember, ketones have an ONE ending. All right, I think everybody's done, so I better get to work. What's different? Look for what's different. what's not carbon, what's not hydrogen, should get your attention like that. Hopefully that got your attention. And we have an oxygen double bond to carbon. Notice we have carbons here, carbons here. It's a ketone. What's the longest chain? 1, 2, 3, 4. This would be 5. But if I go across 5, 6, 7, the alkane would be heptane. Drop the E at ONE, heptanone. Notice it's on carbon 2 right here, 2-heptanone. Then we have on carbon 4, our old friend, the methyl group. And why don't you draw the following compound? It's an old friend of mine. I used that to get my first patent, this molecule. Wow, really old friend. I hate to ask this, how many of you are around in 1985? Think about that, that's when I got my first patent. Wow, I just did the math. 20 plus 15, that's a long time ago. Remember, Al ending, aldehyde. Thank you, Joe. And Joe, did you get my email?
Oh, about the project?
Yep.
Yep, yeah, I got that. It's uploaded.
Okay, great. And I think everybody's done. So how do you decode this? You start from this side and you look Al ending, that's an aldehyde. And Dr. White loves aldehydes and ketones. And if that were E, hexane, 6 carbons. And because it's an aldehyde, you can put it on the right or left. I do it on the right. And this is carbon 1, and on carbon 2, I have an ethyl group. And that's my old friend. Say hello to 2-ethylhexanal. And I use that molecule in a way nobody else ever did before, which is why I got a patent. And the product they're using to make that, using that molecule is still being sold. Wow, nice life of that compound. Now, there are 2 common names I asked you to learn. One is formaldehyde. That's the simplest aldehyde when R is a hydrogen. And the other one is acetone. That's the simplest ketone when R and R prime are methyl groups. Now, don't forget, formaldehyde is dangerous. This won't be on a test. If you ever have any problems or questions about formaldehyde, I talked to you about the Katrina trailers. Now, wood products are better now, but if it comes from China, it might not be. I'm not giving off formaldehyde, but always feel free to email me. And acetone, you should know, is one of the 2 molecules used for nail polish remover. If you remember on test number 2, I asked you 3 points. Give the name, give the name of a product, that contains an alcohol, ketone, or aldehyde, name the molecule that's in that product, and name what functional group is it. And you could have put down acetone, ketone, nail polish remover. And you could have also put down ethyl alcohol or ethanol, alcohol, and either in gasoline or better one, it's in vodka, one of Dr. White's favorite. Now, one of the most important things I know in all of organic chemistry is the carbonyl group. And notice I even have IMP, which means important. And on test 2, I asked you, and you should know how to describe with words and picture what is the carbonyl group. And the carbonyl group is a double bond, is a carbon double bond to oxygen, which I have the words here, and I have the double bond to carbon right there to oxygen. And 2 things more can be bonded to that carbon. This is something you should know. This is probably the most important thing I know in all of organic chemistry to me personally. Because if someone were to ask me, Dr. White, what kind of chemist or what kind of organic chemist are you? And I would immediately say, I'm a carbonyl synthetic organic chemist. Most of my important discoveries, not all, but most, have come with my knowledge of what I could do with, have fun with a carbonyl group. And you can have fun with them. All right, now I've already talked about this. To take a primary alcohol and oxidize it, you get an aldehyde. If you take a secondary alcohol, oxidize it, you get a ketone. Now, a special reaction, Friedel-Crafts acylation, is if you take a benzene ring and an acid chloride, aluminum trichloride, you make an aromatic ketone. And this is important in our world because aromatic ketones are used in many things, especially something called photochemistry. And since you haven't studied probably started studying for the final, hopefully you are this week, I'll help you out. And there you go. What would be the product or products for the following reaction? If there's more than one product, I will help you out by putting a plus sign there. If there are more than one start, and sometimes I'll do a question mark, sometimes I don't. I'm inconsistent there. And that is the most ugly looking benzene ring I've ever, not ever, but now I feel better. I keep up the quality in this class. Everybody done? All right. What do we have here? Benzene ring. Carbonyl with a chloride and acid chloride. What do we get? An aromatic ketone. What's our ethyl group? Benzene ring, carbonyl. What's our 2 carbons? And that's how you get it. And you should know how to do synthesis problems with this. My memory serves me correct. I think it still does. I put that on test number 2. Did you see the screen with the whiteboard that I just did? All right, hold on one second. Let's try this again. There, all right. Did you see the problem I gave you before with the whiteboard? Thank you. Zoom just burped on me. Sorry about that. Anyways, you should know in the next 4 reactions are reactions we practiced that students have difficulty with, but you didn't because you practiced it by taking aldehyde or ketone. If R prime is H, it's an aldehyde. If R prime is carbon, it's a ketone. React it with acid and water. Keep your eye on the carbonyl carbon, carbon double bond oxygen. You go break the pi bond and you get this hemiacetal or hemiketal. This and the next 3 reactions, I will never give you a synthesis on the final. You have my word on that. And I never break my word, especially when I give it to myself, which I just did. Next, if you take an aldehyde or ketone, react it with 2 molecules or moles of an alcohol with acid catalyst. Keep your eye on the carbonyl carbon. That now has 2 OR groups. And this is important because that's how starches are made, acid hydrolysis. Now, there's a special case, which I talked about, Herbert Stork, which was my advisor, Dr. William Rush's advisor. So I guess he's my grand advisor, whatever that means. Came up with a very important thing in organic chemistry called the protecting group for aldehydes and ketones. And you react ethylene glycol acid with a ketone or aldehyde, and you get this ketal or acetal, which is easily taken off. Students, I don't know why I forget to put that carbon-carbon single bond here. Don't. Now, once you have these, what can you do? You can reverse the reaction. If I have an acetal, hemiacetal or hemiketal, add acid or water, the carbon with the 2 oxygens comes a carbon double bond to a carbonyl. Carbon with the 2 oxygens here becomes a carbonyl. R prime or H and R double prime are still on there. And the R group on the oxygen becomes this alcohol. So you get the aldehyde or ketone plus the alcohol you use to make that hemiacetal. You have a hemiketal. I forgot the H next to R prime. Sorry about that. You have a ketal or acetal, acid and water. Again, both of these are the only place in organic chemistry where you have 2 oxygens single bonded to the same carbon. Again, this is the only place in all of organic chemistry where you have 2 oxygens single bonded to the same carbon. And here you get back the ketone or aldehyde you would have used to make that acetal, excuse me, plus the alcohol you would have used. If you want to put a 2 there, you can, you don't have to. I wouldn't. Now, something that Dr. White really loves, take an alkyl halide, react it with magnesium, you get a Grignard. X can be chlorine, bromine, or iodine. Remember, the R group, the carbon with the halogen is bonded to the magnesium, and the magnesium is bonded to the halogen. If you reverse that, I'll mark it wrong. Now, this Victor Grignard won the Nobel Prize for, because once you make the Grignard reaction, named after him, you react it with an aldehyde or ketone, and this makes a carbon-carbon single bond. And this reaction, reacting a ketone to aldehyde, first step, Grignard, second step, acid and water. I will never, ever give a synthesis. The oxygen fell off after H2. Sorry about that. So let's go back and have some fun with this. Now the water has and why don't you give the product or products for the following reaction? And since you may not have started studying yet, I'll help you out today only. Shh, don't tell anybody I'm being nice. Your turn. Wow, this afternoon went fast. Time flies when you're having fun with organic chemistry. I hope it does for you. All right, everybody done? I guess so. What's different? Ooh, carbon double bond to oxygen. It's got carbons here and here. It's a ketone. And our prime and our double prime are methyl groups. Oh, let's look here. Carbon, oh, magnesium halide. That's a Grignard, and I didn't put down here. X can be chlorine, bromine, or iodine. And this is my R group, triple prime. And now, let me make a little more room over here. Keep your eye on the carbonyl carbon, because that's where all the fun is. And what's attached to it, our prime is still there, and our double prime. And then you'll have a hydroxyl group. And what's our triple prime? The carbon with the halide, with the Grignard, will be the carbon bonded to the carbon with the alcohol. And now we've made a carbon-carbon single bond, something very rare, something very special, and something fun to do. I used this reaction in my PhD thesis a number of times to make molecules for my research. Now, a carbonyl is a carbon-carbon double, or carbon-oxygen double bond. If you add hydrogen to catalyst, you break the pi bond, because it's pi and sigma bond, and each carbon, I did it again, each atom of the double bond gets a hydrogen, and you make an alcohol. Now, if you add a double bond, you don't want to use hydrogen and catalyst, and Dr. Brown of Purdue discovered or created, and he won a Nobel Prize for it, reagents, and one of those was lithium aluminum hydride, LiAlH4. And if you take an aldehyde or ketone, and first step, lithium aluminum hydride, second step, acid and water, you do the same thing as hydrogenation. You break the pi bond, and each atom of the double bond gets a hydrogen. And that's how you do that. Now, I can rush through the next one. I'm going to wait till Wednesday. And this will give me a little time to tell you, all right, don't forget, a week from today will be the final exam. Don't forget, Wednesday, at the end of class, I will do, and it's totally optional, I'll end a couple minutes early so you don't feel like you're late for your next class. I will teach some important aspects of how to interview or how to do a successful interview, either to get into school or, more importantly, to get a job. And that will help you a lot. I will cut it out of, how do you like that? Cut it out of the video. And don't forget, the deadline for the extra credit project, if you're planning on doing it, is this Wednesday, end of the day, let's call it midnight or something like that. But before then, either come to my office hours today or Wednesday, or email your project if you're planning on doing it, and I will check it. And with that, I'm done for today. Thank you for stopping by. Gang gesund. Bye now. I'll stick around if anybody has a last minute question.